Hi guys, so today's topic is about percent yield. It's kind of like the limiting reagent thing in that we are assuming that everything always works perfectly, but in the real world, things don't always work perfectly. You've got your idealized version of all the mathematics of everything, but in reality, not everything always works out perfect like this. So, for example, if you've ever made like grilled cheese sandwiches, maybe you got a big old loaf of bread, and your limiting reagent is the fact that you have 8 slices of cheese. If you've got more than enough bread and only 8 slices of cheese, then theoretically the only thing that you could make would be 8 sandwiches. But anybody who's ever made grilled cheese sandwiches knows that, you're going to take one of those slices of cheese and just eat it straight up, or maybe drop it and give it to the dog or whatever. But maybe by the time you're all done making grilled cheese sandwiches, you only have 6 sandwiches that you actually made. Now, you started off the whole process, and you should have been able to create 8, but you only ended up with 6. So your percent yield is a 75% yield, 6 out of 8, because you should have been able to make 8, but you didn't quite get there because of factors that were perhaps beyond your control, perhaps not. So percent yield is this equation here. It is the actual divided by the expected times 100%. So this guy here is your theoretical. That's what you should have gotten. Those are the things that you should have done according to all the math. The actual yield is what you did get. So the actual yield is what you did get. And for the purposes of these problems, the actual yield is going to be a number that is going to have to be given to you. They're going to give you that number. Basically, what you are going to have to do is you are probably going to have to calculate how much you should have gotten and then compare that to how much that you actually did get in the laboratory. That number is going to be presented to you. So let's take a look here at an example of this. So it says in the reaction, we have 35 grams of that compound reacts with excess of the boron compound to produce 4.5 grams of the other boron compound. What is the percent yield? So again, let's be clear. Let's come down here. The percent yield is going to be did over should times 100%. Now, they gave you the did. This is the did. You did get that much. So you got 4.5 grams of that. The only thing that you have to do now is figure out how much you should have gotten. So how are you going to do that? Well, you're just going to do a normal stoichiometry problem. So here's our real world. Here's our mole world. You've got 35 grams of that compound, and it says that you have excess. Oh, that's so nice, because it's not a limiting reagent problem then. Oh, wonderful. So all we got to do is come down here. We realize that, see, sodium is 23, boron is 10.8, and there are 4 hydrogens. So that stuff weighs 37.8 grams. So 35 divided by my 37.8 grams per mole is going to be a moles of 0.926 that you actually have. Now, what do you want? You want to know grams here that you should have gotten. So what are we going to do? We're going to head over here by a 2/3 ratio, because again, you have to take that mole factor into account. So multiply that by 2/3, and you should end up with about 0.617 moles here. And then all you got to do is work your way back up into the real world units, realizing that it's 10.8 twice, and then 6 more for the hydrogens is 27.6 grams for the molar mass for that stuff. At the 0.617 is going to get you about 17 grams for your theoretical. So that's 17.0 grams that you should have gotten theoretically. So according to all of the math, I should have gotten 17.0 grams. But because of whatever factors, I only ended up with 4.5 grams there. So 4.5 out of 17 gets me a percent yield of about 26.5%. So percent yield, they're going to give you the did. You have to calculate the should by using a normal stoichiometric process. Divide the two out and you're done. Let's try another one. Let's see. I have my real world, and then I have my mole world down here. It says I have 50 grams of this, and I only get 25 grams of this over here. So again, that's what I did get. So I can go ahead and plug that into my equation right down here. My percent yield is going to be did over should times 100%. My did is 25 grams. So I did get 25 grams. But how many should I have gotten from this process? So I don't need my did anymore. But I'm going to have to go down, over, and up using a normal stoichiometric path. So what? Phosphorus is 31 4 times, and then another 160 for the 10 oxygens is going to be 284 grams for that stuff. So dividing those two guys out, you should end up with 0.176 moles that you have. You have to work your way over by a 4-to-1 ratio. So we're going to multiply that by a 4-to-1 ratio. So I should have 0.704, give or take, moles that are there. And now I need to know the grams. So that's 64 for my oxygens and 31 and another 3. That stuff weighs 98 grams per mole. At my 0.704 gets me about 68.9, about 69 grams that are you should be getting. So this is 25 grams that you did out of 69 grams that you should have. So 25 out of the 69 gets you about a 36.2% yield. So again, they are going to give you the did. That's going to be given in these types of problems. But otherwise, it's a stoichiometry problem with a twist. And that is it.